Okay, welcome back to part 2 of our programming robots to control a photosynthesis experiment. Now, in our previous lesson, we looked at how we could program a simple loop that would wait 5 seconds, turn its motor on to raise a milk carton for 6 spins, because we actually physically turned the knob on the robot and counted 6 spins. 360 degrees is one spin, times 6 gave us 2160 degrees. Then it would stop for 8 seconds, and then it would lower itself back down 6 spins and stop for 11 seconds, and then it would loop, starting all over again. Now, what we're going to do today is, based on the group you're going to be assigned to. Now, some teams are going to be assigned to 1 hour of sunlight per day, some will be assigned to 8 hours, and so on and so forth. Now, in the previous example, we were simulating a 24-second period, kind of to mimic a 24-hour period, which is why we have 5 seconds here, plus the 8 seconds here is 13, plus the 11 is 24. Now we're going to be inserting thousands of seconds into these boxes to simulate longer time periods, to simulate hours at a time. And we're going to be copying and pasting this entire loop a few times. That is all dependent on the number of hours that your plant is assigned per day. Now, if your plant is assigned, say, 8 hours per day, you can simply have the milk carton raise once during the entire day for 8 hours, and then after 8 hours, just come down once, and that's it. And then it waits another 16 hours before it does that again. And this loop would pretty much suffice. But in our case, we're going to do an example where the plant is assigned 3 hours of sunlight per day, and we're going to have the robot spread those hours out during the day. So it's going to raise the plant first from 8 a.m. to 9:30 a.m. That's an hour and a half. And then at the end of the day, of the school day, let's say from 3 p.m. to 4:30 p.m., it will raise and expose the plant again. So we need to do some calculations over a 24-hour period, and that 24-hour period needs to be converted into seconds. So to get those numbers and those calculations, we're going to jump over to Excel. Now, I've posted this on the website, the Robots Plant Experiment Calculator, and I've already put together some formulas in here for you. Now, just to give you a little exposure on how Excel works and how the formulas work, basically every cell in Excel and in Google Spreadsheets can act as a formula or a calculator. For example, here if I type in 1 hour, I get 3,600 seconds. If I type in 10 hours, hit enter, I get 36,000 seconds. How? Because in this square over here, this cell, I typed a formula. Here, let me clear the formula that's there. Okay, and I'll start over just to give you an idea of what I'm doing here. Every hour has 60 minutes. So 1 hour converted into minutes would have to be 1 times 60, and every minute has 60 seconds. So every minute would have to be multiplied by 60 seconds. And that's how we would convert an hour into seconds. So what I would have to do to enter formula is type equals. You always type equals first, which means you're starting a formula. A3, whatever is typed into A3, I don't know what number you are going to type into A3. So I'm just going to specify a variable as A3. There we go. Times, it's the little star sign above the number 8. So if you do Shift 8, you should be able to get that star sign, depending if you're using an English keyboard or not. Times 60 minutes times 60 seconds. Then I hit return, and now my formula is in there and it converts that 10 hours automatically. If I put 5 hours, hit enter, there you go. See, now I'm changing the variable. I'm changing A3, and it gives me my answer over here. I did the same over here for minutes into seconds. So if I go to the seconds column, I typed in over here, you can see the formula equals D3. If you go to D, and there's 3, that's cell D3, times 60, so each minute times 60 seconds converts the minutes that I type here into seconds. So if I change 10 to 5, there we go, we get a different answer. And you'll also notice that I put in a formula for hours. That's D3 divided by 60. It's going the other way. Okay, so now I know how my calculator works. I know how to enter in formulas. Now it's time to map out how many seconds the milk carton will be down and for how long it will be raised. So I've made a little legend here. Orange is exposure to sunlight and gray means it's in the dark. Now you'll notice that 1 hour, let me go back up over here, hit 1 hour, has 3,600 seconds. So a half hour would be divided by 2. 3,600 divided by 2 is 1,800 seconds. So I broke each cell down into half hour increments. Okay? So if I want to do 90 minutes of sunlight starting at 8 a.m. in the morning for my robot, here's what I'm going to do. I'm going to make this all orange so I know that is a sunlight exposure period. And then over here, I am going to, let's say, right up to 3 o'clock. I'm going to make that dark. There we go. And then we need another 90 seconds, which is 3 cells, 1 half hour, 2 half hours, 3 half hours is 90 minutes. We'll make that orange again. And then the rest of the day over here is gray. Okay, so now what I've got to do is get the totals for the orange areas and the gray areas. Now, you can do this in one of many ways. You can do 1,800 times 3 here. Let's try that. Go equals 3 times 1,800. Hit enter, and it gives you your first total. And then here we have, using my arrow keys, I can count the cells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that would be equals 11 times 1,800. Hit enter. There you go. And there's 19,000. So you see we're breaking our day down into seconds. You can also do this another way. You can use a formula if you want. Here, let me use the automated formula up here. This is sum. And automatically it puts sum parentheses B22, but I could give it a range, B22, and include, let me extend this up. There we go. I grabbed that little corner, the little dot on the anchor of the corner, and dragged it up. And you notice that it's B20 colon B22. That means sum up B20 up to B22. And you can see that it's boxed them in here. It's giving you an advance notice of what it's going to add up. I hit enter, and there you go. It did that automatically. And you'll notice I got the same answers over here. That was 90 minutes. This is 90 minutes. That formula option becomes really handy when we get over here to the last cycle of our day, the remaining moments in darkness. I'm going to go back to sum. And by the way, you can actually just type this in. You don't have to get the automated formula. You could go sum, and again, grab that corner up here and drag it all the way up to here, and then hit enter, and you get your answer, 55,800 seconds. As I mentioned, you can manually type it in. You could always look over here. You see B23 to B53. So you would just type equals sum, open parentheses, B23 colon to B53, close parentheses, hit enter, and you'd get, by manually typing the formula, you'd get the same answer. All right, so that's how we use our calculator, and there's our spreadsheet. Okay, so now how do we transfer these totals into our program? Let's jump back over to LabVIEW, and let's assume that we come in at 8 in the morning, and we don't really have to wait here. We don't need this time, this wait for. I'll put it at 0. You don't even have to wait. There. And immediately, so as soon as I turn on the robot, this program turns on, and as soon as the program turns on, I'm assuming I'm turning it on at 8 a.m. and therefore this program will kick in automatically, raising the milk carton immediately by 6 spins, because we already measured 6 spins. 360 times 6 was 2,160 degrees. That's positive 2,160. And then it will stop. How long, so the carton is in the air now, the plant is exposed to light. How long do we want it to break for that carton to stay up in the air? Well, if we flip back to our Excel spreadsheet, we want our plant to have 5,400 seconds of light. So let me go back to LabVIEW and type in 5,400 seconds. So the carton will wait, staying up for that amount of time. Okay, so after 5,400 seconds, which is an hour and a half, the carton starts to come back down. It reverses minus 2,160 degrees of spin, and then it stops. How long do we want it to stay in the dark? So now the carton is down. Let's go back to our spreadsheet, and we could see that it will stay down for 19,800 seconds. So let's type that, 19,800 seconds. Okay, now you'll notice that we need some more programming because we now need to expose our light after 19,800 seconds. We need to give it 5,400 seconds again. And we're going to need to lower it again for 55,800 seconds. So we're missing a bit more programming, but in this case it's quite simple. We're going to take our arrow tool here and let's make this loop a little bigger. I'm going to draw a box around here and move this down here. And now I'm going to draw a box with my pointer tool around that entire code, and I'm going to copy, Command C, and then Command V paste, and move that down here. And I'm going to grab my wire, my spool of wire over here on the top right corner, click once, come here, I'll click, turn my wire down, click to turn again, click one more time, click, and then come to the top left corner, and now my program is joined. I've just added another loop. But I'm basically, this is like a routine, and I'm basically going to reperform this first routine again over here. Now actually I don't even need this time. This little time guy I don't need yet because he's been in the dark for 19,800 seconds, after which we want the motor to raise the carton. So let's actually delete this little time thing, and that ruins my wire. So I can just go to Edit, Remove Broken Wires, and start again. Click here, click, 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 and right here. There we go. Take my arrow tool and get rid of that. I could have left that little clock there at 0. It wouldn't have done anything because it was set to 0. Now our motor rises for 6 spins. The carton is raised. It stops after 6 spins. How long do we want it to stay raised and exposed to sunlight? Once again, if we come back to our Excel spreadsheet, it says 5,400 seconds. I already have that entered in here because I copy pasted earlier. And then after 5,400 seconds, the motor will go back down for minus 6 spins, or minus 2,160 degrees. It will stop, and now we need to say how long it needs to stay in the dark. Let's jump back to our program, and we see that the remainder of the day from 4:30 p.m. all the way to 8 a.m. the next day totals 55,800 seconds. So I go in here, take my type tool, 55,800 seconds. So after being in the dark all night, 8 a.m. hits, so the program jumps past this time clock and starts over, back over here, starting the next day. So this is a 24-hour. If you add these seconds up, 5,400 and 19,800, 5,400 and 55,800 seconds, you will see that those seconds total 86,400 2,400 in total. If you were to do the math yourself, you'd see that that's the total, representing a 24-hour period. So we just converted 24 hours into seconds, and we plugged those seconds into the program, and in this way we have a 24-hour clock running. And after it gets to the last icon at 8 a.m., it jumps back over here and starts over again and runs the same sequence the next day. And we will do this sequence, allowing the robot to run for 2 to 3 weeks, and we will take measurements at the second week and at the third week to see how much progress our plant has made under this 3-hour program done in LabVIEW. Some of you will be assigned 8 hours, some of you will be assigned 7 hours, some will be assigned 1 hour, and we will compare the impact of sunlight on the growth of plants accordingly.